In this video, we're going to talk about loop statements in MATLAB. The first type of loop statement that we're going to discuss is the for loop. The general form of the for loop is to write the key phrase for, and then a space, and then a loop variable. This loop variable is going to be changed, and that loop variable is going to be changed over a certain range. That range is most likely a vector. And then you're going to take an action inside the loop, and that action often refers to the loop variable as a vector address. And then you need an end statement to complete the task. So let's do some examples of a for loop. The first example is going to be called for echo. So I'm going to navigate to MATLAB, and I'm going to open a new script, and I'm going to comment, and I'm going to say this script is for echo. This is actually an example from Stormy Attaway's textbook on MATLAB, the link to which is shown in the description below. So in this example, this script loops to repeat the action of prompting the user for a number and echo printing it. So what I typically do to start my MATLAB files is that I use close all, clear all, and CLC just to get rid of any extra variables that are hanging around, to close any command or close any figure windows, and to clear the command window. Here I want to repeat the user input 5 times, so I'm going to set my loop variable using that same strategy, for loop variable, and that has a range, most often a vector, in this case 1 to 5. So for iv equals 1 to 5, input num is equal to input enter a number, and then I'm going to do fprintf to display the output, and then I need an end statement, and then all I need to do is to click run, and it will ask me to save. I'm going to save this as the script for echo, and it's asked me to enter a number. I'm going to enter that number in the command window. It tells me that number, and it's going to repeat this 5 times and then end. One thing to note, if I click run again, if I want to stop the execution of a program, I can hit Control-C and it will terminate the program. This is especially important when you're doing stuff with loops, which could run over and over again, and you might want to stop quickly. Alright, the next example is called sum in nums. And in this example, I just want to write a function which is going to set a set of n numbers. So let's create a new script. It's a function, so I start with the keyword function, and I want to output run sum is equal to sum in nums of n. Alright, and sum in nums returns the sum of the n numbers entered by the user. And the format of the call is sum in nums of n. Alright, to do this I would first initialize the variable run sum, which is my output variable, but it's what I'm going to be updating within my for loop. Then I'm going to start my for loop, for I equals 1 to n, and then I'm going to ask the user to input a number each time. Input is equal to, and I want to make sure that I name this variable appropriately, input num is equal to input enter a number, and so then I want to do run sum equals run sum plus input num. So what I want to do is make some comments just to say get a number from the user, and then in this step what we're doing is we're updating the running sum with new number, and then I just need to hit end. So since this is a function, I need to call it from the command window, and I first need to save it as the name of the function, sum in nums. So let's go ahead and save, and then I just need to go ahead and copy this and put it into the command window, and then put an actual number in. So let's say 4, and if I enter the number 1, 2, 3, and 4, then it's going to run 4 times, and it's going to take the running sum. So we've got 4 plus 3 plus 2 plus 1, the sum is 10. The next example is called for input vec. This is also going to be written as a function. Let's start a new file. Function numvec is equal to 4 input vec of n, and the function for input vec returns a vector of length n. Again, this is another example from the Attaway textbook. It prompts the user and puts n numbers into a vector, and the format of the call for input vec of n. So I first initialize the vector. Num vec is zeros 1 to n. I will fill in numbers later, so this is initialize the vector. Alright, this is a very common thing that I need to do before I run loops. I often need to pre-allocate space. I also may want to define variables that I'm going to update. So iv is equal 1 to n. Again, I'm going to ask for an input number from the user, and then I'm going to set the value of the ivth address of the vector, num vec, to be input num. So this is one of the most common uses for a for loop, is that I step through a vector, and that vector represents addresses in some other vector. Alright, so let's say that again, get input, and then in this command what I'm doing is update the ivth vector address in num vec to contain the input number. Alright, again, I need to save this because it's a function, so I want to go ahead and in my command window type for input vec, and this could be any number. Let's make a length 3 vector. So 1, 3, and 5, and this returns vector that contains 1, 3, and 5. Alright, the next thing that we can do is what are called nested for loops. The general form of a nested for loop is to set an outer for loop, which steps a first loop variable over a certain range, and then an inner loop, which is contained as one of the actions of the outer for loop, and this inner for loop will step over a different loop variable with a different range, or possibly the same range, and perform some action. The main reason that we do this is to execute commands on every single address in a matrix. To understand how nested for loops look, we're going to do some examples. The first example is called print stars. So coming back to MATLAB, this print stars code is going to print a box of stars. The number of stars is specified by the loop variables, which give the number of rows and columns. So this is not a function, so I can use close all, clear all, and CLC. Then I'm going to set a variable called rows, which can start with 20, and columns, which we can start with 30. And then we're going to do a nested for loop, where outer loop will loop through the rows, and inner loop will loop through the columns. So for k equal to 1 to rows, for every row we will print, in this case, 30 stars. Okay, so we'll step through the rows, and we do for m equal to 1 to the number of columns, f print f star. We need to use f print f because we want them all to be in the same place. So I need an end statement for the first for loop. Then I need, after I have gone through all of the columns, I need a new line. So I'm going to do f print f slash n, and then I'm going to type end to finish off. And if I run this, what happens is that I get 20 rows of 30 stars. All right, you can count that to confirm, but that is exactly what you get, 20 rows of 30 stars. The next example is called SumOnlyPos.m. In this example, I'm going to use some data values which I already have saved. So before I even write the example out, I'm going to clear all, and then I'm going to load data vals, so that way we can see what is there. It's data vals looks like this. You can go ahead and create this file if you so choose. If not, you can just follow along with the example and understand what's going on. First thing I'm going to do is I'm going to sum, or I'm going to comment, and I want to sum only the positive numbers from the file. So let's first do close all, clear all, CLC, and then I'm going to load my data vals. And what I notice about data vals, since I already looked at it, is that it's a matrix which is 3 by 6. And so I want this to work no matter what size this is. So I'm going to do r comma c is equal to the size of data vals. Alright, so what this does is it gets the dimensions of the file. And I'm going to use this to step through every single value. So I'm going to start with a for loop for row equal 1 to r. First thing I want to do is set a running sum equal to 0. And this is going to update every time I go through a new row. And then I'm going to nest a for loop in this for column is equal 1 to c. And I'm going to avoid doing too many comments here because I'm saying them verbally. So for column equal 1 to c. Then I'm going to use a decision if data vals of row comma col. Alright, these are my loop variables, row and column, is greater than or equal to 0, then run sum is equal to run sum plus data vals of row comma col. Alright, so if this value at that address is greater than 0, I'm going to add to my running sum. Alright, after the end statement, I needed to end that for loop. Then I'm going to go ahead and type in that the sum for row %i is %f in, that /n for a new line. The first variable I display is going to be row, which is an integer. The next variable I display is going to be a floating point number, which is run sum. And then I need one more end statement to finish off, and then I can go ahead and run this. And it says the sum for row 1 is 11, the sum for row 2 is 3, the sum for row 3 is 8. If we want to check that that is true, we can just do data vals, and I can sum up only the positive numbers, and I can in fact verify that the program has behaved correctly.
The next type of loop that I'd like to talk about is a while loop. The general form of the while loop
is that I have some condition, and I'm going to run the loop as long as that condition is true. So while some condition is true, I'm going to run an action, and that will repeat as long as that condition is true. So often I need some sort of decision statement inside the while loop to get me to change that condition. So let's look at some examples. The first is going to be called fact gt high. This problem is going to be a function fact gt is equal to fact gt high of high. The comment for this is that fact gt high returns the first factorial value, which is greater than the input number. And the format, of course, is fact gt high of some input integer. All right, so k is a value that I'm going to initialize first to be equal to 0. This variable is something that I'm going to increment in order to calculate the factorial. I'm going to also start with the factorial of that value 0, which is 1. And then I'm going to start a while loop. And while fact is less than or equal to the value of the input integer, which I'm calling high, I'm going to increment k to be the next number in the sequence. And then I'm going to calculate the factorial for that number, which is equal to fact times k. Then I'll put an end statement. So this will continually update. It'll find the factorial until the factorial is bigger than high. And then I'm going to set my final variable fact gt to be equal to fact. I need to save this, and then I can run it. I just need to put in fact gt high of some number. All right, we could try maybe 10. And so I'm going to find the first factorial, which is bigger than 10. All right, so 24 is 1 times 2 times 3 times 4. So that's 4 factorial. So we're looking for the first factorial bigger than 10. That confirms this is the first time, because 1 times 2 times 3, which is 3 factorial, is only 6, which is less than 10. The next while loop example is called count pause num. We're going to count pause num. So let's go ahead and make a quick comment. This is going to prompt the user for a positive number, and it will repeat exactly what the user is entering as long as the user enters positive numbers. In addition, it will count the total number of positive numbers entered by the user. So first I set my counter equal to 0. Then I'm going to ask the user for an input outside of any loop. Input, enter a positive number. Next I'm going to start a while loop, and I'll say while input num is greater than or equal to 0. We're going to fprint you entered a whatever number it is, where the number is specified in the variable input num. Alright, and then what I'm going to do is update my counter. Counter is equal to counter plus 1. And then finally what I want to do is I want to get a new input num. And I'm going to do that just by copying and pasting this. It's very important that I do it in this order, so that way, because the way that this condition up here in a while loop is checked is that it's checked after the last command within the while loop. So this is the last command within the while loop, so I can put end down here. And so the way this will execute is it'll get a positive number, it's going to print what it is, it's going to update the counter, and then it's going to check the value of the number or get a new value for the number. And if this value is not positive, the while loop will end. If the value is positive, then we've hopefully started with one positive number. If it is positive, then I'll come back around. I'll say this is what you entered, and then I will update the counter. And so then hopefully I'll have two positive numbers, and so on and so forth, until I enter a number which is not positive. And then the last thing I need to do is I need to tell the user, thanks, you've entered a certain number of positive numbers. So if I go ahead and save and run, I'm going to call this count pos num, and it says, okay, enter a positive number. So I entered a 3. But let's say I enter a 6. Let's say I enter a 5.4. All right. Now let's say I enter a -3. And that's not a positive number, so the while loop ends. And so I've got 3 positive numbers, and it is fine. The final example I have is more about timing. So it turns out that I'm able to A, check how long things take to run in MATLAB, and B, see a difference when making loops if I pre-allocate the vector. We're going to do an example which is called tick-tock pre-alloc, or in fact tick-tock pre-alloc, if we want to get real rhyming, or pre-allocating values. Alright, so this example shows the timing difference between pre-allocating a vector versus not. So I'm going to start by doing clear all, close all CLC. Then I'm going to display first for the user no pre-allocation. Alright, then I'm going to go ahead and type the command tick. What this does is it starts a timer. Then I'm going to go for I equal 1 to 1, 2, 1, 2, 3, 4. Alright, and if you're keeping track at home, that's 1 million. X of I is equal to the square root of I. What I'm doing is I'm making a vector which is filled with the values of the square roots. Then I'm going to go ahead and put talk, and what that does is it counts the amount of time since the previous tick command. On the other hand, what I can do is pre-allocate, which is really much better and saves us time. Alright, so tick, then I'm going to pre-allocate a value y, which is equal to zeros of 1 million. Then I can do for I equal 1 to 1 million, y of I equals the square root of I. And then I'm going to put a talk command. So even though there are more commands in the pre-allocation, what we're going to see is that the pre-allocated vector saves time in the loop because it doesn't have to recreate the vector every time. So let's go ahead and test this. Tick, talk, pre-alloc. Alright, so you can see that I save time. It turns out that the very first time with no pre-allocation, the value of time is about 0.34. For pre-allocation, the value of time is faster, and if I run again, sometimes it goes more quickly. It just depends on what the processor is doing. In this case, the pre-allocation saves us a factor of 2 in time. And so when I have really long values or really long vectors that I'm creating, what I'm going to find is that the time it takes to execute could be much shorter. Now, here's something interesting. Let's say that I repeat the first one, and here I'm going to say no semicolon. So if I run this with even a value of 1,000, which is much less than 1 million, I expect that without the semicolon, this is going to take a significantly longer amount of time. Almost there. Wait for it. There we go. So without the semicolon, this last loop that I made took 16 seconds to run. 16 seconds. That's a lot. So that tells you why I want to use a semicolon. If I zoom all the way to the top of my command window, in fact, the command window doesn't go back that many lines. So I'm not even able to see what the other ones were, but I can guarantee that they were less than 1 second. All right, with that, that concludes everything that we need to learn about loops. I would suggest looking at Stormy Attaway's book and doing quite a few examples and problems from the chapter on loops. That's it.